Chapter 2, Linear Equations and Functions. Section 2.1, Relations and Functions. So a relation is a mapping or pairing of input values with output values. And we can represent a relation in one of four ways. We can look at a set of ordered pairs, and here I have listed a set of ordered pairs. We can put those ordered pairs in a table, or also called a t-chart. We can graph those ordered pairs. So if we graph them, the first thing we're going to do is graph the point -2, 2. So we need to move first in the direction of the x, so back 2, -2, and up 2 is the point -2, 2. -2, -2, again graphing the x first, but then going down 2. The point 0, 1, so we're moving 0 on the x-axis, but 1 on the y-axis. And then the point 3, 1, so over 3 and up 1. We can also use a mapping, and the way we deal with a mapping is we're going to list the x-coordinates, so we have -2, 0, and 3, and even though -2 is listed twice, we only have to list it in the mapping once, and then the members of the domain, again in numeric order, so -2, 1, and +2. And then for a mapping, if we look at our first one, -2 is mapped to +2, so we just draw an arrow from the -2 to the +2. -2 is also mapped to -2, 0 is mapped to 1, and 3 is mapped to 1. So the arrows basically represent what y-coordinate the x-coordinate is paired with. You also might hear, when we're talking about a relation, we also often will call it an input and an output, or the x and y coordinate. X is also called the domain and y is the range, or the x-coordinate is the independent variable, and y is always dependent on that x-coordinate. So we're going to consider the relation given by this set of ordered pairs, and the first thing we need to do is to identify the domain. Well, again, the domain are all the x-coordinates, so if I look at the x-coordinates and list them in numeric order, I can see that my domain is -1, 2, 3, and 4. My range then is going to be my y-coordinates, which is -1, 0, and 2. And again, we're only listing those values each once. So some key things to keep in mind when identifying your domain and range is, first of all, it's a set of numbers, so make sure that you use brackets. You're going to list in the domain and range, list them each in numeric order, so from the smallest up to the largest. And then you're going to list each value only once. So even though we see that the value 0 occurs twice in the y-coordinates or the range, we're only listing it once. Now we're going to represent the relation as a graph and as a mapping. So go ahead and try to do that on your own. So once we've graphed all the points, the graph should look like that, and now let's go ahead and do the mapping. So again, we've listed the values that are our x-coordinates in the first box and the values that are our y-coordinates in the second box, and now we just have to draw an arrow for our ordered pairs. So 3, 2. 3 is mapped to 2, -1 is mapped to 0, 2 is mapped to -1, 4 is mapped to -1, and 3 is also mapped to 0. And so this is what our mapping would be. Now a function is a special kind of relation in which each input has exactly one output. And so what this means is basically that your x-coordinates cannot repeat. So if we look at our first example, tell whether the given relation is a function, we can see that because 3 is mapped to 0 and -1, this is not a function. If we look at the second set of ordered pairs, if we see -3 is mapped to only 5, 0 is mapped to only 5, 2 is mapped to only 6, and 6 is mapped to only -8. So it doesn't matter that my y-coordinates repeat. If my x-coordinates have only one value output value each, then it is a function. The vertical line test tells whether a relation is a function, and a relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. What this means is I should be able to draw any vertical line I want anywhere on the graph, and it will only ever intersect the graph at one point. So this first one is a function, but if you look at the second one, even though I can draw some vertical lines that intersect it only once, since this vertical line intersects it more than once, this is not a function. So an equation in two variables can be in one of two forms. We can have y equals mx plus b, where m and b are real numbers, and we can have ax plus by equals c, where a, b, and c are real numbers. This first one is called slope-intercept form. Hopefully you're familiar with that. And the second one is called standard form. And in standard form, it's also important that a, b, and c are integers, which means, if you remember what an integer is, that they're whole numbers. So a, b, and c should not be fractions. So when we're dealing with equations in two variables, we're also talking about solutions. And a solution is an ordered pair, so x, y, that when it's substituted into the equation is going to make the statement true. And so that's how we can always check our answers, is to put our solution back into the original equation and make sure it makes a true statement. And so a linear equation is also typically, unless it's a vertical line, going to be a function. So a linear function, we're familiar with y equals mx plus b. But now we're going to be introduced to a new notation, and this is called function notation. And this is read f of x equals what? Mx plus b. So it's not f times x. We're not ever going to be dividing by f to solve for x. It's important that you realize that f of x and y mean the exact same thing. So if you ever see an equation with f of x in it, you can always replace that f of x with y. And so now a few examples. First of all, tell whether the function is linear, and then evaluate the function when x equals -3. So to begin with, part A, f of x equals -2x squared plus 5. This is not linear because there's an exponent, and so it can't be written in the form of mx plus b. But now let's go ahead and evaluate this. And so the way we can write this is f of -3. So in other words, we're replacing the x with -3 because that's what it tells us up in the directions. And if we replace the x with -3 over here, we need to remember that we replace the x in the expression with -3. So all we've done is we've replaced the x with -3. So f of -3 equals -2. Again, remembering your order of operations tells us that we have to do the squared first. And so again, remembering that -3 squared is a +9. And so continuing on, we get f of -3. -2 times 9 is -18 plus 5. F of -3 equals -13. We're not going on any farther to solve for f. This is our answer. This basically means that when x equals -3, y equals -13, where we have the ordered pair -3, -13. The second example, g of x equals 12 minus 8x. This is linear because it could be written in the form of y equals mx plus b. And now we're going to still evaluate that at -3. So g of -3 is, again, we're replacing the x with -3, so 12 minus 8 times -3. G of -3, we have 12. -8 times a -3 is going to give us a +24. So g of -3 is 36. And again, we could write this ordered pair as -3, 36. When x is -3, y is 36. And now we just have some practice evaluating functions at different variables. So again, we're going to be using this f of x function, And so f of, in this case, 4 is 3 times 4 plus 2. Just doing the order of operations, we get 12 plus 2. So f of 4 is 14. Go ahead and evaluate the function at f of negative 5, and then check back and see if we get the same answer. Hopefully you got that f of negative 5 is negative 13. And now let's try to evaluate it at f of h. And in the same way that you can't simplify 3x plus 2, all this is doing is telling us that we're going to replace x with h, so that over here we must still replace the x with h. We still can't simplify this, so f of h is simply 3h plus 2. This one gets a little bit trickier, but not a lot. F of m plus 3. So again, we're remembering that we just need to replace the x with m plus 3. So 3 times m plus 3 plus 2. Again, all we did was we replaced the x with m plus 3, 3 times that, and then the plus 2 remains in place. So can we simplify this? Well, of course we can. We can distribute the 3, so we get f of m plus 3 equals 3m plus 9. We still have the plus 2, so f of m plus 3 equals 3m plus 11. We can't simplify it anymore, but we can get it to that point. And now let's try f of 4x. Go ahead and try this on your own and see if we get the same answer. And there wasn't a lot of simplifying, but you should have gotten that f of 4x is 12x plus 2. Please note how I modeled the work that I would like to see, and show your work similar to that on your homework, please. Make sure if you have any questions, you bring them to class, or you write them in the notes check. Speaking of which, please make sure you go back to the website and you do the notes check. And we'll see you in class tomorrow.